Okay, welcome to lesson 813. Once again, we're going to try to work through this together. We're going to kind of move through this a little quicker, I think, than the last lesson. So just try to keep up, pause the video if you need to take a minute, and we'll see how you do. Today's focus is going to be on how to write an equation from a graph. So let's just take one of these, okay? So for instance, I've got, we'll look at B together, okay? So for part B, I want to try to write an equation for that, right? So my equation has to take into account all of the roots in the graph. That's really important. It also has to take into account our minimum degree, and it has to take into account what our end behavior is, whether it's a positive orientation or a negative orientation. So start wherever you want. We could start with the idea that this is a negative orientation since the right side of the graph is pointing down. So what I know is I'm going to have a negative out in front of the entire thing. I also know what all of my roots are, and I can see that here at that root at 0, that it looks sort of like a slide, which means we're probably looking at triple root there. So if I start thinking about this in terms of writing the equation now, I know that x equals -3 is a root. So working backwards, that would mean that x plus 3 would have to be a factor. I know that 0 is a root. Working backwards means that x has to be a factor. That's my slide, so I'm going to make that cubed. And then I know that x equals 2 is a root, which would make x minus 2 a factor. Now this would be great, except if you actually graph this on Desmos, what you'll find is that we get a slightly different graph. Similar shape, same root, same end behavior, but slightly different. So we've got to do something else here. And the something else I have to do is take into account the stretch factor. So we have Melvin writing out this equation to represent this graph. And he's got the roots, he's got the end behavior, he's got the degree good, except if you pick any point on this graph, it might not match when we put it in the equation. So I've got to figure out a better equation by finding the stretch factor. Now to do so, I've got to use a point that's not the x-intercept on my graph to help me write this equation. So if we look down at part B, they actually give us a point here that goes through our graph, and that point is 116. Now I'm going to use that to help me write the equation. So here's what I know. I know that I have got this equation y equals x plus 3 times x plus 1 times x minus 2 squared. And I know there's some stretch factor in there that I have to find. What I do is I take this point, 116, which has an x and a y in it, and I plug it in. So if I put in 16 for y and 1 for x, so 1 plus 3 times 1 plus 1 times 1 minus 2 squared, now I've got a way to find out what my stretch factor is. So go ahead and solve for a here. Come back and check your work when you're done. Hopefully you come up with a equals 2. Now from that I can write my equation, right? So my equation is going to be p of x equals 2 times, and then what I'd already written, which was using all of the intercepts. So that's my equation. So the key here, guys, is you've got to figure out your a value. You've got to find your stretch factor. So what I'd like you to do is try writing an equation for part A and B of 849, making sure to get your stretch factor. Pause the video, come back and check when you're done. Okay, so check what you've got with what I have. That doesn't look as much like a negative as it should right there. That is a negative, negative 3/4. But you'll have these equations that I always start out using the roots with a as my stretch factor until I actually can solve for it. And then a lot of times you'll have a nice point given to you that you can use. It doesn't always have to be the y-intercept. It could be any point on the graph. Okay, go ahead and try 850. It might help you to sketch a graph first and then come back and check your work. All right, so here you go. If you needed to draw a picture, you might have drawn something that looks similar to this, right? We have it passing through 4, bouncing off of -1, and going through the point -218. So not many other ways you could have drawn this, but that can be a helpful guide. You didn't need to do it because you know that it bounces off the x-axis, which means that you know that it has to have a power of 2 here. We also know that it crosses the x-axis at 4, which means it has to have a root of 4, which gives us a factor of x minus 4. And then we can use our point, -2, -18 for x and y, to solve for our stretch factor of 3, and then write our equation. Now we have Armando coming up with this other equation, which is very similar to ours. Only difference is he's got a 4 instead of a 2. So we have to ask ourselves, does it fit the criteria? Well, it has a stretch factor that's the same. It has, a bounce here. If you look at the graph on Desmos, a squared or any even powered factor here is going to give you a bounce. It's going to flatten out the higher that power gets, but it's still a bounce. And then we have it passing through 4. What you have to decide is it the same? Okay, so will it fit all the criteria, including going through this point? So stop the video for a second and see if it will actually pass through this point by plugging in -2 and -18 into his equation. So when I plug in that point, -2, -18, I get a true statement using Armando's equation. But what if we also said there was an additional point that we knew that this graph went through that was 1, -36? So now we have a little bit more information here. So do the two equations both work now? So pause the video and try to see if this x and this y will satisfy both of the equations that are written. And then come back and check. So hopefully what you found is that the two equations don't both work for that point. What changed our equations was the idea that our bounce could have been either 4 or 2 or any even number. What would really help us is to know what our power of our function needed to be. What's our highest power? What's our degree? So when we're looking at writing the equation, I really should tell you the degree of the function as well. And once you know that, then you can write the equation. Because if I told you the degree of our function was 3, then we could write this equation right off the bat, because I would know that this can't be more than 2. Otherwise, I would have a higher power than 3 on the entire polynomial. Okay, nice work. Check Classroom and get your assignments done for the week, and we'll see you in chat.